asking us to prove AD over BD is equal to AE over EC. This is a proportionality theory. We are given that DE is parallel to BC. We're going to prove this using the areas of a triangle. We know that when we're working with triangles, if we use an area of a triangle, say this triangle, for instance, the area of the triangle will be half base times height. For some triangle, we know that the height is within the triangle itself. With some triangles, in some triangles, we have to draw the height outside by extending one of the sides. In some triangles, the height can be drawn within the triangle, whereas in some we have to draw it outside. We're going to use this logic and apply it on this thing. The first thing that we're going to do here is construct some of the lines. Construction. We're going to draw line H1 and H2. This is going to be H1. This will be H2. An important thing to realize is that within the triangle ADE, within this triangle, we have two heights. We have height 1 and height 2. So when we calculate the area, we can calculate the area of this triangle DAE, which has a height of H2, as well as the area of the triangle AED, which has the height of H1. But beyond that, we can also construct lines on this thing. So we've drawn line height H1 and H2. We're also going to draw in join DE and DC. So we're going to draw. That's the BE, and then we're going to join DC. So within the quadrilateral BDEC, we have two triangles that we're going to look at. We're going to look at triangle BED as well as CDE. Remember, we did say some triangles have the heights within, such as these two. This triangle has the height within, or this triangle has the height within. Some triangles, we have to draw the height outside. So if we look at this triangle, B, D, and E, this triangle with the green line, its height is going to be H1. Its height is going to be H1. When we look at this triangle, C, D, and E, its height is going to be H2. So if we draw them outside, it's going to be D, E, B. Its height is going to be this one, H1. And for triangle height is going to be h2, height 2. Height 2. What we want to do is find the ratio of triangles that share the same height, because we do know that the ratio of triangles that share the same height is equal to the ratio of their bases. How do we do this? Let's say the area of triangle ADE. Let's take the one that has the H1 height. So area is going to be half base. The base is going to be AD multiplied by height is going to be H1. The ratio of triangles that share the same height, we also want another triangle that has a height of H1. This triangle BED, remember, some triangles we need to draw the height outside of the triangle. So this triangle BED has a height of H1 outside. So area of triangle BEE is equal to, we're finding the ratio of the base. The base for this one is going to be BD, the height. So the ratio of areas that share the same height is going to be equal to the ratio of their bases. Our reasoning, triangles share same height. We move to height 2. Area of triangle ADE is going to be half the base AE multiplied by H2 over area of triangle CDE the base is going to be DC multiplied by height 2. From this point, we can write the same thing here. From this point, we have our ratios. We realize that we're also given that BC is parallel to DE, but we haven't used this information. How we're going to use it now is that we realize that within this quadrilateral BCED, we are told that DE is parallel to BC. And within this, we have two triangles, DEB and DCE. These two triangles share the same base. They share the same base, DE. They share the same base, which is DE, and they lie between the same parallel lines. This means that the area of this triangle is equal to the area of this triangle. The area of triangle BDE is equal to the area of triangle DC, because they share the same base, which is DE, and lie between the same parallel lines. And since we know this, we can fit these two, the area of triangle ADE over the area of triangle BDE. We can equate these two to the area of triangle ADE again over substitute these two. Over half AD times H1 is going to be equal to half AD H2 over half BC H2. We have common halves H1 half H2. Therefore, we're left with AD over BD being equal to AE over BC. That's what we're trying. This is what we wanted to prove. AD over BC is equal to AE over EC.